Thank you to WAI Australia for having me as part of your event today. My name is Jill Meyers, coming to you all the way from America, and I'm here to talk about aerospace engineering. So first of all, what is aerospace engineering? Well, there's two parts to it. Part one is aeronautical engineering, which is all about things that fly below the Earth's atmosphere. So airplanes, helicopters, hot air balloons. And that atmosphere ends at about 100 kilometers from the Earth's surface, and it's commonly called the Kármán line. Astronautical engineering is all about things that go into space beyond the Kármán line. So rockets, spaceships, any of those things. And even though my degree is actually in astronautical engineering, I spent most of my 30 plus year career working on airplanes because that was really my early passion. I did work on satellites really early in my career. I worked on a system called GPS, which you may recognize. Obviously, there's a GPS chip in every one of your cell phones. And I used to work on things that are on the GPS satellite, let's leave it at that, for security reasons, many, many years ago. So you may be wondering how I got into all this and how this passion started. Well, when I was 12 years old, my family took a vacation to a friend of my father's who lived near a town here called Boston on the east coast of the United States. And he owned a small airplane. It was a Cessna 140, which is what we call a tail dragger, meaning that instead of having tricycle landing gear under the front part of the airplane, the back wheel is actually behind the tail, so it looks like it's dragging the tail. My dad's friend took me up in this plane for about an hour when I was 12, and that was it. I was completely enamored with flight, fell in love with the airplane, and decided then that I wanted to do something with aircraft. We happened to live about a mile from a really small airport at the time, so once I got home, I would ride my bicycle to the airport on weekends and just sit at the edge of the runway and watch the airplanes take off and land, and I thought that was just amazing. And I actually went into the building at one point and asked them if I could sweep the floors or wash the planes, anything to be around them on weekends. And they pretty much said, no, you're 12, come back when you're older. So I did. And in the United States, you have to be 17 to get your private pilot certificate. So when I turned 17, I was in my final year of what we call high school. I think you call it secondary school. And I started taking flying lessons really early in the morning before school started, and ended up taking about 6 months of training when I was not in school, and actually got my private pilot certificate halfway through my senior year in school. After graduating, I decided to join the United States Air Force, and I first went into the Air Force office with my pilot's license in hand. And they looked at me and said, well, you're a girl and we don't do that. This was in the 1970s, and they were not really letting women join the Air Force to fly. But I joined anyway because I knew I really wanted to be around airplanes, and that was a great way to do it. And honestly, a great way to get college paid for here. So I joined the Air Force. I spent about 8 years in the military, and I worked as a computer analyst, but I used to work on computers that ran ground systems that helped control aircraft. So not working on airplanes specifically at that time, but still in and around them all day long. And my favorite was a time I was stationed in Germany at a really, really tiny base that's not there anymore. But it used to be a base for the A-10 aircraft. It's an attack plane, and it's commonly known as the Warthog because some people think it's not very pretty. But what I loved about being around the A-10s is that when they fly, they do what's called close air support, and they fly really low to the ground and really slow because they communicate with troops on the ground to provide them support. But I thought they were one of the coolest airplanes I've ever seen. And while I was still in the Air Force, I got accepted to a very special program where I went to college full-time to get my aerospace engineering degree, and also stayed in the military during that time. I went to a university in Texas called the University of Texas at the Austin, Texas headquarters. And I want to talk a little bit about what it's like to get a college degree in aerospace engineering, at least here. This first chart shows you the major categories of classes that you take. There's many classes under each of these, but the major technical classes you take, of course, you still have to take other electives and stuff, but aerodynamics and propulsion is the first, structural mechanics is the second, flight controls, flight mechanics, and orbital mechanics for those who want to go more into spacecraft than aircraft. There are many classes, as I said, under each of these, and on this next chart, you will see the actual curriculum for the University of Texas Aerospace Engineering degree. It's probably hard to read, but you can look it up online, and I'm sure other universities have very similar programs. But it's a very intense workload, it's very highly technical, and my best advice to students that are considering an aerospace engineering degree is to take as many STEM, science, technology, engineering, and math classes that you can earlier in your school before you even get to university. When I was in high school, we were very lucky to have what's called advanced placement classes in my junior and senior years. And what that meant was our school offered very technical classes that were really college level as far as the content. And when you took these classes, if you got an A, the highest grade, you would actually get college credit for those courses. So when I was in high school, I took every single advanced placement course we offered, which included English, calculus, physics, chemistry, and biology. I took all of those. And it really gave me a base understanding, more important than the college credit. It gave me a base understanding of those really hard technical subjects before I even set foot at university, which I would highly recommend if you have that opportunity to do that in school, that you think about that. Next, I want to talk about where you can get these degrees. Of course, there's a lot of schools around the world that have aerospace degrees. What I show on this chart are two that I found, and you know more than I do about this in Australia, but RMIT in Melbourne offers a program, as well as the University of Queensland. On this chart, though, I wanted to point out one school in particular to you all, which is MIT, the Massachusetts Institute of Technology. I'll start by saying it's one of the most difficult schools to get into in our country. And what I like about it, though, are two things. First of all, some of the universities you go to, like when I went to school, is my degree is actually, my diploma says aerospace engineering. But when I was in school, I had to select either aeronautical or astronautical and could only go one of those two tracks. What I like about the MIT program is it's called the Aero-Astro program, and you graduate with an equal knowledge of both aero and astro. Secondly, especially with this being a Women in Aviation International event, at least in the United States, MIT has one of the highest percentages of female enrollment of any aerospace program in this country. I believe they're between 30 and 35% women, which is saying a lot for at least the universities here. So once you get this degree, what can you do with it? Well, first I want to talk about just general kinds of work. One is you can be an engineer that goes into what we call design and test. It's also sometimes known as development. That's actually using computer-aided design systems and designing aircraft and spacecraft and testing the components of them. The second is really the manufacturing, the building of systems, which is super fun as well. And in this photo, it's actually a photograph of one of the Boeing facilities here in the United States. You can also work on aircraft test or aircraft system test. Like in this photo, you see an engine being tested. But you can also be the kind of engineer who tests an entire airplane or an entire spacecraft. Really, really, really fun kinds of jobs. And next, I just want to highlight the kind of the job titles that you can have with this degree. It's a huge range. You can be a design engineer. You can be what's called a systems integration engineer, which is what I was. You can get into management. You can get into the business side. You can be a professional pilot, either military or commercial. And yes, you can even be an astronaut. You don't have to have an aerospace degree to be an astronaut, but some of them do. And in my opinion, it's not a bad path to take toward being an astronaut. So now the fun part, to give you a better idea of some of the really cool things you can do as an aerospace engineer, I thought I would highlight some of the programs I worked on because I've been very lucky to work on some really amazing platforms. The first is the AWACS. We call it here in the US the AWACS, which stands for the Airborne Warning and Control System. So this is a Boeing plane. This particular photo is of a Boeing 707, very old aircraft, that has a large radar on top of it. It's called the rotodome. This happens to be the NATO version of this aircraft. I've worked on the US fleet, the NATO fleet, and the United Kingdom, the UK fleet in my career. And what's really crazy about this airplane is it can talk to other aircraft in the sky, it can talk to ships at sea, it can talk to troops on the ground, but all of those speak different languages basically. So what the AWACS platform does, it's also called AEW, Airborne Early Warning. It takes messages from all of these different things and it converts them into a common language and spits it back out. So it's kind of like a big translator in the sky. I was very lucky. I worked on this the first time when I was in the Air Force in Germany on the NATO fleet, working more of the operational side. But later when I left the Air Force, I worked at Boeing and actually was a manager in charge of all of the systems engineering to upgrade the entire radar on every airplane in all three fleets at the time. And what was challenging about that, which is a really good example of a hard engineering problem in aerospace, is this airplane was built in the mid to late 1970s, and here we were 20 years later having to put a brand new high technology digital radar system in it with really old electronics. So it was definitely a challenging integration problem, but we figured it out and we updated, I believe, almost 60 aircraft around the world with much, much better radar systems so they could perform better for the troops that needed them. This next photo is of the Australian version of the AEW system. So this is a project called Wedgetail. And when Australia came to Boeing and said, we'd like one of these, please, they really didn't like the aerodynamics on the big radar that was a really old design. So at Boeing, we redesigned the radar to be what's called an I-beam, because when you're in construction, there's a beam that looks like the letter I if you look at it on edge. So we took a 737, a newer aircraft, put this I-beam radar design on it, and I believe you have, I shouldn't say, I don't know how many you have, but Australia's been taking delivery of the Wedgetail for quite some time. But it's a really great platform. So next I want to talk about remotely piloted aircraft. So when I was in the Air Force, that's all we call them, RPAs, remotely piloted aircraft. They're more commonly known as UAVs, unmanned aerial vehicles, or UAS, unmanned aircraft, or unmanned aerial systems. And yes, a lot of people call them drones, which is a term I'm not fond of, but my favorite remotely piloted vehicle I ever worked on is this one called Global Hawk. And I picked this photo of Global Hawk because there's people in it and you can see how big this thing is. So Global Hawk is a remotely piloted aircraft and it is basically all cameras and sensors. It flies really high. The numbers are really classified, so I can't tell you, but it flies really high and it stays aloft for almost a full day. And this has been delivered here in the US to the United States Air Force, to NASA, and to an organization here that's in charge of weather forecasting. So they took a few of these and used them to assess the weather situation from a very high altitude. Again, Australia is one of the customers. So Northrop Grumman builds this vehicle, and they took it and converted it several years back into a model called Triton. And Triton is specifically designed to fly better over water than over land. So it basically is a maritime patrol system that patrols the coastlines of a given country. And I believe from my research that 3 of these have been delivered already to Australia, although I think there's 7 or 8 total on order. So it's really nice to have worked on platforms for me personally that have been delivered to your country, which is really great. So next I want to talk about my favorite thing I've ever worked on, the F-35 Joint Strike Fighter Jet, which was renamed a while back to be called Lightning II. F-35 is the most advanced fighter jet ever built, and it is planned to replace the F-15, the F-16, the F-18, the Harrier, yes, the Harrier. And the reason is there's 3 models of the F-35. This one shown is the F-35A, which Australia Defence has also purchased. The F-35A is what I'll call a regular jet design that flies like a regular jet. The F-35B, or Bravo, actually can fly vertically as well as horizontally. It has a really awesome design feature where, I'm going to make it sound really simple, like a lid lifts up behind the cockpit and it creates the ability for a vertical funnel of air, and it can also fly like a helicopter, which is why it will replace the Harrier. And then the F-35C, the Charlie version, is for the Navy, which will be able to go on an aircraft carrier and let the wings fold. So the wings are designed to fold so they can be parked close together on an aircraft carrier. And again, you guys have ordered the A version, and it is, I believe, I'm not sure it's been delivered yet, but I know Australia has placed a lot of orders. So what did I do on the F-35 program? It was like I said, it was the last real cool aircraft I worked on. And I was one of 2 managers in charge of delivering and building and delivering all of the communication and navigation equipment on every F-35 aircraft for any country. So we ended up building 42 pieces of hardware, systems that went into the F-35 and handled all the communications the pilot needs to do and all of the navigation systems, except GPS, because you just buy a GPS thing and stick it on. But it was an amazingly fun program to work on, which I did several years ago. Now I want to pause for a minute, and I was asked to talk about challenges, and I want to be really upfront that one of the biggest challenges in aerospace engineering as a career was being a woman. I was very often the only female in my organization, on my program, and it didn't bother me as much as it seemed to bother others, but it was sad to see such a small percentage of women, and I think you may all be aware of the low percentage of women in all of the fields we work in. In aerospace engineering in particular, we are about 12 to 13% of all aerospace engineers are women. And in fact, the percentage of women in all engineering fields in the US is right about 13 or 14. And what was interesting is this is still a problem today, which we all face. And when I got hired by Northrop Grumman, who is the company I worked for when I worked on the F-35, this was just a few years ago, mind you. And when I went into my first staff meeting, the very second or third day of work, the room was literally filled with me and 21 men. The whole room, me and 21 men. That was the management team for this program. And it's just shocking to me that it's still the case today, which is why WAI exists as an organization to try to really shift that balance and get more women into the field. How did I handle it though? What my philosophy has always been is just to go in and do the very best job I can and just do the best you can. And for me, it's worked out obviously fairly well. I want to shift for a second and talk about one special commercial airplane I worked on. So I worked mostly military aircraft because of being in the Air Force and loving that environment so much. But I also worked on this really awesome airplane called the Eclipse 500. It's a twin-engine jet that holds 6 people. But what's special about it is, unlike most jets of that size, it flies up at the 40,000 foot altitude with the airliners. So it's very special, and I worked for this company that built it, and I was in charge of systems engineering, which I've mentioned previously. It was an amazing program to work on. The airplane, there's almost 300 of them out delivered around the world. They actually let me fly it once as a co-pilot when I worked there, and it was absolutely amazing. I loved it very much. Someday I'd like to buy one. Okay, now, as you may have gleaned from my presentation so far, there's a lot of really cool things you can do in aerospace engineering. But what I want to talk about for a second are some skills, some characteristics that I think help you be a better aerospace engineer. The first is you really need to be able to understand complex technical issues. And to go back to what I said earlier, taking that base coursework when you're younger in science and math classes in particular will help you get there and help you build that skill to understand complex technical issues. Now, the other side of it is really good engineers, in my opinion, are also really good problem solvers. So the ability to take those really hard issues and figure out what to do about making them better, making issues go away, or improving the performance of an aircraft, or even making it cheaper to build. Those are all things that really good aerospace engineers need to be able to do. But I will tell you, in my opinion, having been in this industry for as long as I have, I really believe the number one skill you have to be a really good aerospace engineer is communication skills. And that may sound funny to you, but the ability for you to communicate with your team members, with your boss, with customers, super important. And I will say, in all honesty, every program I've ever been on that failed, I believe it failed at its core because of poor communication between people. So your ability to communicate both verbally and in writing, super, super important. So please keep that in mind. So the next thing I want to talk about, kind of the last thing I want to talk about, is what is next. So if you go to Aerospace Engineering College today and get your degree, what might you work on when you graduate? So to me, there's a couple of really cool things going on. The first is supersonic flight. This is an airplane that's being built by a company here in the United States called Boom, because of the sonic boom. It's called Boom Supersonic. And what supersonic means is that the airplane will fly faster than the speed of sound. And by the way, if you don't know, I shouldn't assume you do, my apologies. When an airplane flies past the speed of sound, it makes a really loud bang called the sonic boom. And the speed of sound is 767 miles per hour, or 1,234 kilometers per hour. It's pretty fast. So Boom is building the first supersonic jet in 60 years. And what's amazing about it, there's other companies doing supersonic work. This aircraft will hold about 50 passengers, and it will fly about twice as fast as airliners today. So for example, you could fly from Sydney to Los Angeles in about 8.5 hours, whereas today it takes almost 15 hours. You can fly from New York to London in just over 3 hours instead of a little over 6. So it's going to kind of have the distance, or rather the time that you fly a single distance, and it's just super, super, super exciting. And then to switch to space for a second, there's a lot going on in the space industry right now if you follow it at all. The first thing I want to talk about is SpaceX. You've probably heard of it, but at least in the United States, NASA, which is the National Aeronautics and Space Administration here, NASA's been the only organization to ever launch vehicles into space until this May. And in May of this year, a commercial company called SpaceX in California launched their rocket, which is called the Falcon 9, and the capsule that held astronauts is called the Dragon. They launched it to the space station, first time in a very long time if ever that a commercial company has launched into space. But what's really my favorite thing about what SpaceX is doing, and it's probably because I'm kind of a geek, most people don't think this is as cool as I do, but let's try. So these next set of photos shows the Falcon 9 rocket coming back down. So what's really amazing about SpaceX is they're the very first company to design a spacecraft where the entire rocket, as soon as it goes into space, the capsule with the astronauts in it gets jettisoned and goes on to like the space station, and the rocket itself comes back to Earth and is reused. What's amazing about what SpaceX is doing is they land the rocket on a platform that floats in the ocean, and there's literally a target in the middle of the platform. As you can see in the photo, it comes and it lands vertically exactly on that platform exactly on the bullseye. SpaceX has never missed once. I don't know how many times they've done it, but I'm thinking it's at least 10. Never missed the bullseye. I think it's amazing as an engineer because that's really, really, really hard to do. And then just a little fun side note, they've named this floating platform, and for some reason it's called Of Course I Still Love You. Look it up, I'm not making it up. So the last thing I'll talk about is, as far as cool things going on, is going, of course, to Mars. This is a really complicated chart, but there's a lot of companies looking at building vehicles that are going to go to Mars. Most of them are using the moon as a launch point. So a lot of, at least what NASA's focusing on here, is going to the moon, building an entire infrastructure, facility, work, and housing on the moon so that we can fly to the moon and then launch from the moon to Mars. It's about a 7 or 8 month trip, we think, from here to Mars, or from the moon to Mars. But there's a lot of people super excited about going to Mars and exploring a new planet. So a lot of people I am mentoring right now, I mentor a lot of young women. Some of the women I'm mentoring are definitely wanting to be on that list of women who get to walk on Mars. So if you're wondering what I'm doing now, well, I started a consulting business a few years ago. And the main reason was, as a consultant, you can work on multiple projects at once. You can work for multiple organizations at once. And I really wanted to be able to do a lot of things and couldn't decide. So I have a consulting business now, and I just want to touch on a couple of things I've been doing because it, again, illustrates different things you can do as an aerospace engineer, or at least with that background. One is, there's a company in California called Whisk, and they're building a remotely piloted, personal, electrically powered aircraft called Cora. And what will happen is you will literally, as a passenger, it holds 2 people, you'll open the door, you'll climb into Cora, you'll shut it, you'll push a button, you'll tell it where you want to go, and it will fly you there. Now, there's really a pilot somewhere manually controlling that aircraft, but I think someday it will be all computers, but we won't go there. That takes too long to talk about. So Cora needed help with systems engineering. Again, that was my area of expertise, making multiple pieces of an airplane work together. So I consulted to their director of systems engineering for about 6 months, a couple years ago, helping them do system engineering better, improving their processes, making sure they knew how to write a proper test program, things like that. It was a really, really fun program. And electrically powered aircraft is another really big thing. And one of the main reasons is aircraft fuel is very heavy. It weighs a lot. And heavy fuel limits the performance of airplanes. It always has. So looking at electrically powered aircraft is one of the ways that engineers are trying to lighten aircraft, make them less heavy so that they can fly better, faster, and more efficiently. Another fun project I worked on, which is really not an engineering project at all, but they hired me because I knew about airplanes, is I worked on a project called Every Student Flies. There's a high school here in Colorado that put together a program to offer every single student in the entire high school, 520 kids, a free flight lesson so they could experience flight for the first time, most of them for the first time, and really see if it lit that spark to get them to want to be a pilot or an air traffic controller or an aircraft mechanic, anything. So I worked on that project and helped them launch it, which was really, really fun and very rewarding. And even with COVID-19 impacting them for a while, it's been a very successful program with them taking not only the high school students up in flights, but they offered flights to the teachers as well. And another thing I worked on, which was honestly one of the most exciting things I've ever done, and it's a good day to be filming this for you because there was big news this week. I helped a filmmaker make a film, a documentary called Fly Like a Girl. And Fly Like a Girl is a documentary. It's a full-length feature documentary film about amazing women in aviation in history, going all the way back to the first woman who ever got her pilot's license in 1911 in France, and all the way through interviewing amazing women today who are doing amazing things in aviation. And I was able to, through my network of friends and colleagues, I helped quite a few people get into the film. I helped the filmmakers scope out the film a little bit. And I'm really thrilled to even have screen credit on the screen. It's kind of crazy. But the big news this week is it's going to be available on iTunes on October 9th, and you can pre-order it now. So if you want to see anything about this film, or you want to go to the website and watch the trailer, I think the trailer is actually on the Apple site as well. But it's called Fly Like a Girl. Definitely check it out. It is inspiring as I can possibly say. It's wonderful. I hope this gives you all an idea of how really great aerospace engineering is. I could talk about it all day. And I have two main pieces of advice to all of you, especially the younger students that are listening today. The first piece of advice, to reiterate what I said earlier, take those STEM classes earlier, take the science classes, take the math classes, the harder math classes. If your school offers an engineering class, which has just started to be offered here in the United States in high school, take the Introduction to Engineering class. My second big piece of advice, and you may not think of this when you're younger, but I'm really big on finding a mentor. So to me, finding a mentor is just as simple as finding someone who's already in a job you think you might want to do. If you're thinking about being a pilot, if you're really wanting to talk to an aerospace engineer, if you want to talk to an aircraft mechanic, go find one. Take them out for, ice cream. Sit down with them and just really learn what the job is about, because not only might you learn that it's really what you think you want to go after, but you actually might find that it's not what you want to go after, which is just as important. So find a mentor, no matter how young you are or how old you are, and try to learn more about what their life in that job is really like. So thank you again for having me today. It's been really great. And I hope you've learned a little bit about this wonderful career. If you want to reach me at all, feel free. You can reach me through my website, which is meyersaero.biz. So MEYERSAERO.biz. There's a contact me page. You can send me a note. I think my phone number's on there also. So thank you again, and please enjoy this entire day.